Okay, let's finish up the notes for 4.3, 4.4a, first theorem of calculus, fundamental theorem of calculus. These are some integral properties that's important to know. It says that the definite integral of f of x from a to a is equal to 0. Okay, so I'm going to use this diagram here to demonstrate what this means. So imagine we have a starting left endpoint at a, and a right endpoint also at a. So if we have not moved from our initial position, then we're not going to be able to have any region for us to find the integral for, so that's why we're going to end up with 0. Okay, so if the upper and lower bounds are the same, then there's no area, there's no region, so that's why that will give us 0. Okay, the definite integral of f of x from a to b is equal to the opposite of the definite integral from b to a of f of x dx. So what that's saying is, let's say the integral of definite integral of f of x from a to b produces a specific value. Okay, and if I flip the bounds around, then my numeric value will still stay the same, but it'll be the opposite. So let's say this gives me 12. Okay, then the definite integral from b to a will produce a negative 12. Okay. All right. The third is just saying that the definite integral of f of x from a to c is equal to the definite integral from a to b plus the definite integral from b to c of f of x dx. So given that b is between a and c. So if I want to find this entire region from a to c, then I can just add the two definite integrals together, definite integral from a to b and definite integral from b to c, and that will give me my total region. All right, example 3, if the definite integral of f of x from 0 to 3 is 4, definite integral from 3 to 6 is negative 1, then I can then find definite integral f of x from 0 to 6. Okay. So I know the definite integral, I can represent this from 0 to 3 and also from 3 to 6. So I have values for these. So 4 plus negative 1 is equal to 3. Okay. For part B, the definite integral of f of x from 6 to 3 is equal to the negative version from the negative definite integral from 3 to 6 f of x dx. So I do have the value for definite integral from 3 to 6, which is negative 1. And if I flip this, then I'm essentially able to match up these two definite integrals. And I know this will result with negative 1, so negative times negative 1 will give me a positive 1. Okay. For part C, we see that our bounds do not change, does not move. So we know from our first property that definite integral from 3 to 3 will produce 0. Okay. Part D, definite integral from 3 to 6 of negative 5 f of x plus 3 dx. Okay, so let me make sure this is more clear. Okay. So if we see this, we have to just be careful that this 3 is inside the definite integral. So 3 it is the integral of 3, and it's not just 3. So we have to make sure we apply the appropriate integral rule for this 3. Okay. We can split this up into essentially two problems. So I can treat this like two separate problems. Negative 5 definite integral of f of x from 3 to 6 plus the definite integral of 3 from 3 to 6. So we know what this value is. The definite integral from 3 to 6 will give us negative 1, so we can make that substitution. However, this is a separate problem that we can use power rule and we can use the first theorem of calculus. The definite integral of 3 is 3x, actually indefinite integral of 3 is 3x, and then we can evaluate the upper and lower bounds, plug 6 in for x, we get 18, plug 3 in for x, we get 9, so 18 minus 9 is 9, so this will produce negative 5 times negative 1, which is 5. This produces 9, so 5 plus 9 is equal to 14. Okay. If the definite integral of f prime of x from 3 to 8 is equal to 10, and f of 8 equals 6, and find f of 3. So we can essentially just use first theorem of calculus. All right. We know that this is true. The definite integral of f prime from 3 to 8 is equal to f of 8 minus f of 3. So rather than using lowercase f and uppercase f, we're just using f prime and f of x. All right. So the relationship between these two is the same thing as little f with big F. Okay. So you'll see a lot of different notations representing f prime, and a lot of different notations represent the original function. So we know this is true, right? This is definite integral from a to b of f of x is equal to uppercase 8, f of 8 minus uppercase f of 3. So if we know that this is true, then we can just plug in the information that is provided from what's given. We know f of 8 is equal to 6, we can plug that in. We don't know f of 3, so we'll leave that alone. But we do know this left side. This left side is equal to 10. So 10 is equal to 6 minus f of 3. Solve for f of 3. Subtract 6 from both sides. 10 minus 6 is 4, so 4 equals negative f of 3. So to find f of 3, we just divide both sides by negative 1. So f of 3 is simply negative 4. Okay, the area for each region is shown below, for example 5. Now this represents area, okay, so that means this portion is below the x-axis. The area is 2, but if we want to find the definite integral from b to c, because this region is below the x-axis, we know the definite integral from b to c of our function will be negative 2. So let's keep that in mind. Okay, find the definite integral of f of x from a to d. So we can simply set up using definite integral and use that notation to begin. So the definite integral from a to d for f of x is simply definite integral from a to b plus definite integral from b to c plus definite integral from c to d. So we're just essentially adding these regions. We know that this will produce a positive 10. Okay, this region has area of 2, but will produce a negative 2 because it's below the x-axis. This region is below the x-axis. And then finally, the definite integral of f of x from c to d is above the x-axis. This is 3, so we combine these regions. So 10 minus 2 plus 3 will simply give us 11.